Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class, I will teach you the second order derivative, some important proof of second order derivative. So this is the second part of second order. This is student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT exam, WJE and JEE main and CBSE board exam confidently with a good rank or a good marks. Now let's start the class. So today's class is on some proof of important some important second order derivative. So first problem is, if x equal to sin t and y equal to sin pt, prove that 1 minus x square d2 y by dx square minus x dy by dx plus d square y equal to 0. So this is very important proof for CBSE board exam. So how can we solve? First we differentiate. First we find dx dt and dy by dt. Dx by dt equal to sin t, that is cos t, and dy by dt equal to p cos pt. Okay, derivative of sin pt is sin mx. Sin mx derivative is m cos mx. Now dy by dx equal to by dt by dx by dt, which is equal to p cos pt divided by cos t. So this is dy by dx. Now proof is what is the proof? Proof is in terms of x and y. What is in this proof? The no term t is present. This is completely in terms of x and y. So we have to bring this term in terms of x and y. So for this we squaring both sides. Squaring both sides. Dy by dx equal to p square cos square pt. Okay, first write cos square pt. Cos square t. Now cos square pt equal to 1 minus sin square pt. We know. Divided by cos square t equal to 1 minus sin square t. Sin square t. So now we can put sin pt. What is sin pt? Y. What is sin t? Sin t is x. So we get dy by dx whole square equal to this. Now into 1 minus x square equal to p square 1 minus y square. We get this. So this is a technique. We prove this expression directly from this expression. For this we have to differentiate both sides with respect to x. So differentiating both sides with respect to x. Now dy dx of all this is u and v rule. So this is u and this is v, uv rule. So first differentiate this. Dy dx of dy dx of this into this constant plus when derivative of this, then this constant. Okay, now derivative of this is, first we write to d2y by dx square, this constant, plus derivative of this is minus 2x into dy by dx whole square, and p square constant, derivative of 1 is 0 minus derivative of y square is 2y dy by dx. Okay, now cancel 2 dy by dx both sides. 2 dy by dx, if we take common 2 dy by dx, we get dy by dx square 1 minus x square minus x dy by dx समान equal to minus 2 dy by dx into p square y. So cancel 2 dy by dx on both sides. We get the required proof. dy by dx square minus x square plus p square. We shift p square y in this side, we get the problem is x equal to sine 1 by a log y, and if this equal to this, so that 1 minus x square by 2 minus xy1 minus a square y equal to 0. Second proof. Here this is in terms of x and y. First, if we express y in terms of x, then this will be very convenient and easier. So we have to express y in terms of x. We have to express y in terms of x. So for this, x equal to this. Now sine inverse, we have sine of log y equal to x. So take this is x, sine theta. If sine theta equal to x, we know theta equal to sine inverse x. Okay, so this is theta. Now equal to sine inverse x. So log y equal to a sine inverse x, which is equal to, now this is base e. Here base is e. So y equal to e to the power a sine inverse x. If this is the basic definition of logarithm, if log a equal to x, here base is e, so a equal to e to the power x. So this is the basic definition of logarithm. Here base e and y equal to, y will be e to the power this. If log 8 base 2 equal to 3, then we can write 2q equal to 8. Okay, 2q equal to 8. Log 8 base 2 equal to 3, that is 2q to the power 3 equal to 8. So e to the power this equal to y. We can write in this way. Now we differentiate this with respect to x. We differentiate this with respect to x. What we get? dy by dx equal to a into e to the power a sine inverse x into derivative of sine inverse x is 1 by root over 1 minus x square. This is chain rule method. We can differentiate this. We can differentiate this e to the power m sine inverse x equal to m into the power this whole things into derivative of this sine inverse x equal to this. Now this is a into e to the power a sine inverse x equal to y. So a y by root over 1 minus x square. Now this term is in term y and x form. No sine, no log term is present here. So let's multiply this. Now squaring both sides. Squaring both sides, we get 1 minus x square into dy by dx square equal to a square into y square. Now differentiating both sides. Differentiating both sides with respect to x. Differentiating both sides with respect to x. What we get? UV rule. This is u, this is b, this is u, and this is b. This is u, this is b rule. So is equal to minus 2x. Then this is constant. And when this is constant, then derivative of this is 2 dy by dx into d2y by dx square. So here derivative is a square. Derivative of y square is 2y into dy by dx. Now cancelling 2 dy by dx from both sides. 2 dy by dx take common first. Now 2 dy by dx cancelling both sides, we get this equal to this. So this is the required proof. Proof is y2 1 minus x square minus xy1 minus a square y equal to 0. So this is the required proof. If y equal to e to the power x sin x plus cos x and y equal to, if y equal to this, prove that d2y by dx square minus 2 dy by dx plus 2y equal to 0. So first we have to find dy by dx. dy by dx equal to, this is u, this is v rule, this is u, so this is u and this is v, uv. So derivative of e to the power x is e to the power x, then this is constant, and when this is constant, derivative of this is this. So if we take common e to the power x, we get sin plus cos, sin cancel, 2 cos x. So this is dy by dx. Next, d2y by dx square. Again we differentiate this both so e to the power x cos x, derivative of e to the power x is e to the power x, then cos x constant plus e to the power x into cos x, derivative is minus sin x. So this is the derivative of d2 by this is d2 by dx square, 2 e to the power x common, cos x minus sin x. So now we put this in, now we put d2 by dx square, we put d2 by dx square, this dy by dx equal to this and y equal to this here we get. So required proof is left hand side equal to 2 d2 by dx square equal to this minus 2 into dy by dx equal to this plus 2 into y equal to this. So what we get, if we take, we get cos x minus sin x minus 2 cos x plus sin x plus cos x. So cos x, now sin x cancel, cos 2 cos x, this and this cancel, so total 0, that is 0. X equal to a into cos t plus t sin t, and y equal to a into sin t minus t cos t. Find d2y by dx square at t equal to pi by 4. X equal to this, y equal to this, find d2y by dx square, this. Now from this we get, first we find dx by dt. dx by dt equal to a into cos t, derivative is minus sin t, plus this is uv rule, this is u, this is u, and this is v, uv rule. So the derivative of t is 1 with respect to t, 1 sin t plus t into sin t, derivative is cos t. So cancel sin t, we get at cos t. Now dy by dt. So dy by dt equal to sin t, derivative is cos t minus derivative of t is 1 cos t minus t into cos t, derivative is minus sin t. So this is this. So cos t cancel. So this derivative is at sin t, at sin t. So dy by dx, first find dy by dx. dy by dx equal to dy by dt divided by dx by dt. So this equal to this by this, at sin t divided by at cos t, which is equal to tan t. We get dy by dx equal to tan t. Now d2y by dx square. So we know d2y by dx square equal to d by dx. Here student make wrong. d2y by dx square is not sec square t, because this is in t. Here we have to differentiate with respect to x. So dy by dx square means first we write d by dx of dy by dx, that is dy by dx of 10t dy by dx into d by dx of dy by dx. So this d by dt of 10t into dt by dx. So derivative of 10t dx by dt equal to this, so reciprocate this 1 by at cos t. Now dy by dx square at t equal to pi by 4, put pi by 4 here, sec square pi by 4 is 2 divided by a into pi by 4 into cos pi by 4 is 1 by root 2, that is this, that is 8 root 2 by, this is the answer. If x equal to a sin t, next problem, a sin t minus b cos t and y equal to a cos t plus b sin t, prove that d2y by dx square equal to minus x square plus y square by y cube. So next proof is this. Now if we find dx by dt, dy by dt, this process will be longer. First we can eliminate t easily, because if we squaring and adding, because same a b constant, a and b is present, so if we squaring and adding by observation, we suppose this is x square, this is y square, if we squaring and adding, what we get? A square sin square t plus a square cos square t. So take common sin square t plus cos square t. Minus 2ab sin t cos t plus minus 2ab sin t cos t plus 2ab sin t cos t, and again b square, this square. So if we on b square cos square t plus sin square t. So if we expand this and this, we get this. Now cancel this and this, cancel this and this. So this becomes a square plus b square. So x square plus y square equal to this. Now this is constant. So x square plus y square equal to this. Now if we differentiate both sides with respect to x, both side with respect to x, what we get? X square derivative is 2x, y square derivative is 2y into dy by dx equal to 0, because a square plus b square, is whole constant term, because we differentiate, because we have to find d2y by dx square, that is only y and x is variable, except y and x, other constant, other terms, other letters is constant. We have to find d2y by dx square. So dy by dx, except x and y, other terms, other letters are constant. So a b constant, so derivative of constant term is 0. Now y square derivative of x with respect to x, so 1 into y minus x into derivative of y with respect to x dy by dx. So this, now dy by, so this is y square plus x square by y cube. So this is proved. If y equal to sin of sin x, if y equal to y, we prove that d2y by dx square plus tan x dy by dx plus y cos square x equal to 0. So first find dy by dx. So dy by dx equal to derivative of sin x is cos of sin x into derivative of sin x is cos x. Derivative of this is take as theta or x. Sin x derivative is cos x into derivative of this cos x. Sin x derivative is cos x. So this is now here two terms present, cos sin x one term, cos x second term. So we differentiate again with respect to x. d2 by dx square we get, this is u, this is v rule, this is u, this is u, and this is v. So derivative of this is minus sin x into derivative of sin x is cos x, this constant, plus when this is constant into derivative of cos x is sin x minus sin x. So here minus we write. Okay, it's minus sin of sin x into cos x minus cos of sin x into sin x plus tan x into dy by dx. What is dy by dx? This tan x into cos of sin x plus y. What is y? Y equal to sin of sin x into cos square x. So when we prove, then we have to express whole in terms of x, because we can then cancel the terms. If x and y are mixed, then we cannot cancel. So we have to express only in terms of x, then we can cancel the terms. So here which terms cancelled? Sin x cos square x. So this and this is cancelled. Minus cos sin x, and this is tan x by cos x. So if we adjust here tan x, sin x by cos x, then this cos cancel. So sin x cos sin x and minus cos sin x whole is cancel. So this is 0. That is record proof is 0. Student, this is the end of the class today. To get such type of video, subscribe my channel. In next video, the JEE main and IIT derivative for IIT JEE problems will be discussed. Okay, thank you. Bye bye.